7.2 is covering the natural base e. So e is approximately 2.71828 and so forth. But it is as x approaches positive infinity. You won't really need this number. You can always use your calculator for that. So going ahead and looking at example 1, simplify each expression. You are going to treat e as it is a variable until you have to find an actual number answer. So this just says simplify each expression. E to the third times e to the sixth. I'm multiplying my bases. So I'm going to add my exponents. So I've got 3 plus 6, which is going to give me 9, and my answer there is just e to the ninth. Right here, you're dividing. If you have coefficients, you divide them. So 16 divided by 4 is 4. On your exponents, when you're dividing the bases, you subtract exponents. So I've got e to the 5 minus 4. 5 minus 4 is 1. So this is just 4e, or 4e to the first. On C, I have a square outside the parentheses. So I'm going to distribute it to everything on the inside, which is going to give me 3 squared times e to the negative 4x, and then I'm going to square that as well. So 3 squared is 9 times power to a power. You're going to multiply your powers, so you have e to the negative 8x. Since you have a negative exponent, you have to drop that down to the bottom of your fraction. So you have 9 over e to the positive 8x. So there you are just simplifying each of those. All right, moving on. Let's look at just a few more. Again, here you're multiplying your bases, so we have e to the 7 plus 4. We're adding our exponents. 7 plus 4 is going to be 11, so our answer there is e to the 11th. If you are dividing and you have coefficients out front, you're going to go ahead and divide your coefficients. So 24 divided by 8 is 3. When you're dividing the bases that are the same, subtract your exponents. So I have e to the 8 minus 5. 8 minus 5 is 3, so I have 3e to the third. And again over here, distribute your exponent into the parentheses, which will give me 10 to the third times e to the negative 3x to the third. Go ahead and distribute that. 10 to the third is going to give me 1,000. And then power to a power, I multiply, so that's times e to the negative 9x. Again, since that's negative, it's going to drop to the bottom of the fraction. If it's not negative, it's just going to stay right where it is. So this one is negative. I'm going to go ahead and move it. 1,000 over e to the positive 9x. All right, so now looking at our next core concept, a function, and there's a lot of highlighting already here. I'm going to go ahead and just explain that. Natural base functions, a function of the form y equals a times e to the rx. So that's similar to the other functions that we were looking at in the last section, but this one has an e in it. These are our natural base exponential functions instead of just regular exponential functions. So the r is in the exponent. If r is greater than 0 and a, the number in front, is greater than 0, then we have exponential growth. So that exponential growth is still going to look exactly like it did before. We're still going to have the 0.01, and then we have the 0.1 and 2.718 because the b value is e. So basically this is going to look like y equals e to the x, possibly have a number in front that's a positive. And then your exponent again is positive. If a is also positive and r, not b, but r is less than 0, so negative, you'll have your decay. Your decay graph will look exactly like it did before. You'll still have the 0.01, and then you'll have the 0.1 and 0.368. It will look like y equals e to the negative x. You may have a coefficient out front that's positive, but anything up here is going to be negative, and it's going to be our decay. So looking at that, here we're supposed to tell whether each function represents exponential growth or exponential decay, and then graph the function. So if I have y equals 3 e to the positive x, 3 is bigger than 1, my x is positive, so that is going to be my exponential growth. Now to graph that, just put that in your calculator. You don't have to put y, you can put f of x, so you can leave it as a function. So you're just putting 3e to the x in the calculator. So if we do that, so on our calculator screen, we're just going to go to the graph and plug in our 3. The e is just to the left. If I can get you to see that. It's just to the left below the rooftop. And it'll give you an exponent, and our exponent there is x. Press enter. That's what your graph is going to look like, so that guarantees it is exponential growth. Press Control T to go ahead and get you a table. Most of your graph is on the left, and it kind of goes up to the right. As you can see, it goes up quite quickly. So we have the 0.03 here, and 1 and 8.15. So if we draw that table, zero, 3, and 1, and 8.15, and plot those points. So I have 0, 3, 1, 8.15. If you want to get a few numbers below 0, you're welcome to get those as well. There's your graph for that one. Make sure you draw some type of table, even if it's just a couple of points, as well as drawing your graph on graph paper. Now then, looking at B, f of x equals e to the negative 0.5x. Looking to see if it's growth or decay. It's positive out front, but my exponent here is negative, so that's going to tell me that I have exponential decay. So again, let's put that in our calculator. We're going to delete what's in there. I guess I have to get the table away first. Press tab, and we're going to plug in e to the negative 0.5 times x. Press enter, and as you notice, you have a graph that is a decay. Press Control T and you'll see your table. Most of your graph here looks like it's to the right, but that's going to be a lot of your decimals. You might be able to get some whole numbers on the left side. So make sure you get at least 0, 1, and then we're going to try maybe negative 1, 1.6. So we have 0, 1, and then we have negative 1, 1.6. If you want to get more numbers than that, you're more than welcome to. And plot those points as well. So we have 0, 1, your negative 1, 1.6, and there's a few others plotted there as well. Okay, so make sure on your highlighting, or if you're drawing a box around your answers, you have exponential growth here, exponential decay here, and then your graph. You can just draw a box around your graph. All right, so looking at a few more, right here we've got y equals 1/2 e to the x. So our x is positive, which is going to leave us an exponential growth. If we put that in our calculator and draw a table that's kind of squished, we're going to get approximately 0 and 0.5, 1 and 1.3, and then 2 and around 3.1. plotting those points will give us this graph here. The numbers are wrong on, oh no they're not, that's a 1. It doesn't look like it, but it is. On this graph right here, pay close attention because the scale is different. So basically it's going by halves. So you have half, 1, 1.5, 2, 2.5, 3. And then here, just because of it being decimals, you have a quarter and then a half, 3/4, a whole, and then 2 more spaces give you 1/2. So you can change your scale to whatever you want to change it to make it work for your graph. All right, looking at number 5 here, y equals 4e to the negative x. That negative x tells me I have an exponential decay. We'll go ahead and get the calculator and plug that in. Oh my goodness, it's going crazy. Okay, let's try a different graph. There we go. All right, so we have 4e to the negative x. There's our decay. Control T. So we have, you notice there's a 4 out in front, so instead of having 0, 1, we have 0, 4. On the one we did earlier, there was a 3 in front, so we had 0, 3 instead of 0, 1. I'm not going to go all the way to 10 there, so we'll have 0, 4, 1, 1 point, about 1.5, 2.5. So that was 0, 4, 1, 1.5, 2.5. And plot those points there. Again, in this graph, it's half, 1, 1.5, 2. Same thing here. Half, 1, 1.5, 2, I believe. Yes. You just can't see that that's a 2. All right. Number 6, f of x equals 2e to the 2x. So 2x up here is positive. That's going to give us an exponential growth. Let's plug that into the calculator and get a table. For this one, we're plugging in 2. This calculator doesn't like me today. 2e to the 2x. There's your growth. And Control P gives us a table. We're going to get negative about 0.3, negative 1, 0.3, and then 0, 2. So negative 1, 0.3, 0, 2. As we were talking about before, there's a 2 out front, so you'll have the 0.02 there. It's kind of like your it's your y-intercept that it gives you. This graph is terrible, so I'm going to redraw it. So here we have 0, 2. I'm going to make these again be 1, 2, so we're skipping there, and we'll skip here as well. So if I have 0, 2, that point is going to go here. And then negative 1, 0.3 is not quite to a half, so it's going to be about right there. And it's going to be a growth. It's not going to touch that x-axis. So there's our graph on that one. Again, make sure to highlight or draw a box around your answers. All right. Last thing here, continuously compounded interest. Make sure you write these down. Your formula for this is A equals PE to the RT. A is your balance, like your balance would be at the end. P is the principal, or whatever you start with, your initial amount to put in. R is your annual interest rate as a decimal, and then T is the number of years. So using that information, last problem is going to be the longest. So we have you and your friend, and yes, guys, please write all of this down. You and your friend each have accounts to earn annual interest compounded continuously. So that's a key thing right there, compounded continuously. The balance A in dollars of your account after T years, so A is in dollars after T years, can be modeled by this function. A equals 4,500 e to the 0.04 t. The graph shows the balance of your friend's account over time. Which account has a greater principal? So which account has a greater principal? Which has a greater balance after 10 years? So there's two things that we're looking for. Our equation is given in the problem, and then your friend's account is right over here in the graph. So there's a couple of things to look at. First, let's just look at information for my account. So for my account, we're going to go ahead and write down the equation. A equals 4,500 e to the 0.04 t. And it says which account has the greater principal and which account has the greater balance after 10 years. So you know that T is your years, so 10 is going to be the T value. P is your principal, so we're going to look at that as well. Now for this one, I can go ahead and find the principal. It's given to me right there in the equation. The principal is $4,500. And that's going to be $4,500. So I'm going to go ahead and highlight that so that I don't lose it. So my principal here is $4,500. If I go ahead and look, and we'll draw a line to keep them separated. If I go ahead and look at my friend's account, then I can get that information from the graph. Right here, that's their starting amount. So their starting T would be 0. At 0 years, they have 4,000. So their principal is going to be $4,000. And we'll go ahead and highlight that so that we don't lose it. We're going to write a sentence to explain all of this at the end so that we can tell which one's greater. Now it says which has a greater balance after 10 years. So all we're going to do there is plug in 10 for T. So we'll have A equals 4,500 e to the 0.04 times 10. So plug that in your calculator. So right here we have 4,500 e to the 0.04 times 10. And that's going to give us 6,713.21. So 6713.21. 6713.21. So that's going to be our balance after 10 years. And then for the friend, what you're going to do there is just look at your graph. So here we have 2, 4, 6, 8, 10. So when T is 10, or my year is 10, I'm going to go up to my graph. If 6,000 is here, 8 is here, that means I'm going to have 7,000 here. Well, halfway between 7,000 and 8,000 would be 7,500. This dot is not quite to 7,500, but it looks like it's about halfway between 7,000 and 7,500. So we're going to say that that balance at 10 years is going to be approximately 7,250 because it's about a quarter of the way up. So again, let's highlight that so we don't lose it. Both of our balances at 10 years. And then we can write down our final answer for both of those. And if we're looking, which one has a greater initial or a greater, greater principal, which is your initial value, and that's going to be my account. So we're going to write down the fact that my account has a greater principal and I'm going to make a note of what that is, and that's going to be my $4,500. And then who had the greater balance after 10 years, and that was my friend. And so write that down. My friend has a greater balance after 10 years. And we're going to write down what their balance was, and that's going to be the approximately 7,250. So we're going to put about on top of that because we estimated. And those are your two final answers. Make sure that you write those as a sentence so that we can tell which one you're saying is greater. And make sure you put a period at the end of your sentence.